questions before I begin? Okay. Perfect. All right, and we are live. Looks like we only have one viewer on the stream, so it's all right. You can watch the stream later. But today we'll be talking about in Android so we've been talking about how to build larger Android applications. So last class we talked about fragments and kind of how that alleviates some of the pitfalls of using activities. Fragments are a lot more flexible. So now we have a lot more flexibility in how we display data to the screen, and we're going to talk a little bit more about architecture and singletons, which I've mentioned before, but kind of glossed over a little bit to save for a different time. All right, so I just want to compare and contrast activities and fragments first, because sometimes they are a little confusing, because the way that I showed them last class, it's almost exactly the same. It's like, okay, well, what's the benefit? So let's talk about it. Fragments provide a reusable user experience, and how does that differ from an activity? Well, an activity can only be, you have one activity, whereas a fragment can be arranged with other fragments within that activity. You can put one fragment at the top, and in the next screen you put it at the bottom. You can make a smaller version of that fragment. So it's a lot more flexible in how many you can show, what it does, etc. So the map view, the web view, and your own custom view can be a fragment. So the map view, as I mentioned, like Google Maps, you can have a map that I developed an application for a client, and they had a whole bunch of offices all over the state. And they wanted a map that showed pins in their, where all the offices were, and then tapping on the pin below the map, like taking up the bottom half of the screen, they wanted the contact information for that office. So not only that is, they wanted to get the location of the device so that if there was an office near you, you could instantly see, oh, there's an office. I think they have one downtown. There was another one out by the mall. There was like one in Meridian, I think. And so again, if you're in downtown, you would see a pin right next to you. You tap on that pin, it would give you the address. And then there was another button that in the bottom half of the screen that you can tap on to get directions. And then that dumped you out into the actual Google Maps application. But it was a really nice way to, again, get information. It would also show the phone number. And because Android is some of the time on a phone, you could do a direct call right there by tapping the button and making a phone call from Android. So anyway, that was handled by a fragment, but on the tablet, you have a lot more screen real estate. And so we had a slightly different interface for that, because if you just showed like they had the phone number, they had the address, and I think they had like the main contact or the office manager or whoever was in charge of that particular office. So you had a couple pieces of data, and that looks really weird on a tablet because it was mostly white space when you're only showing that little bit of data. So we did a couple other different UI stuff on that. But anyway, that just allowed us to do it with fragments. Fragments control only their views. So again, if we go back to the Google Maps example, I can communicate from my parent activity that contains that fragment, or that the fragment is contained in. I can say, hey, Google Maps, I want to place a pin at this location, and you talk to that object, right? The activity has a reference to the fragment, and you can talk to the fragment and say, put the pin here, or zoom in, or zoom out, or that kind of thing, controlling it. Well, it's not controlling it, but it's interacting with it, and the map is doing its thing. But the map itself holds just enough information to display itself and do the things that it needs to do. It doesn't necessarily need to know that your Google Map is contained, or it itself is contained in an office display, right? It doesn't need to know anything about the office manager or the phone number, any of that functionality. It just needs to know what it does, and it'll do that one particular task, and that's to show maps and that sort of thing. Okay, so again, markers, web pages, or oh, sorry, I skipped a line. No, actually, that's the next one. So the markers in the maps, you can communicate that to the fragment from your activity or from another fragment if you want to. Web pages from the web view. So think about it this way: you have a URL bar, which is a edit text basically at the top, that will communicate to the web page at the bottom part of the activity and say, this is the URL that I want you to go to. And so the web page doesn't need to know anything about an edit text, because you might have a custom edit text. You might have one that drops down a menu that auto-completes and all that fun stuff that you get from the Chrome browser, right? But again, there's this container that just displays HTML. So just does one thing, contains all the information, just enough information to do the operation. And the last thing here is fragment transactions. So adding that transaction like we added the fragment in our last class, it allows for a back or swapping out of those activities. So for example, maybe I don't have any office selected, and so you want to make that map disappear or transition out or fade away. But you're like, oh, I didn't want to do that, so you hit the back button and you can get that view back. Activities can, as I mentioned, display multiple fragments. So you might have a map view, and below that you might have a web view, and below that you might have some buttons or edit text to manipulate those objects. And so that's an example of multiple fragments with other UI elements that go directly into the activity, but again, mixing and matching. The activities can be launched from another activity or another app. So when I dumped the user out to get directions to that office, I was actually launching Google Maps, and you can deep link into certain apps and say, like for Facebook, for example, if you want to add a friend, you would say to the Facebook application, open up, but open up to this particular user's page. And so you give it as a parameter, and then Facebook would look at that. Basically, it's like a URI. And would look at that URI and say, okay, well, it's parsed in a particular format that I define, and so I'm going to pick out these pieces, and okay, it's a user load operation, and then I'm going to take the user ID out of that and do the thing that I need to do. But basically, it's a URI or a URL that deep links into it. But that's based on an activity. You launch an activity, you don't launch fragments, right? You don't, because fragments always live inside activities. The third point here is activities can use fragments without a UI as invisible workers. So maybe, I don't know if you would necessarily do this because there's a whole API to do this, but let's say you needed some kind of map functionality. Maybe I wanted to add a pin, 2 pins, and then maybe get a distance. I don't know, I'm just making stuff up. And the map view does that really well, but I don't necessarily need to display it. Well, I can instantiate the fragment, add those pins to it, but never add it to the UI. So that's kind of a lame, example of how you would use a fragment without a UI. Activities can choose to display more fragments if it's a tablet. So I don't have a marker to write on the board, and the 7 people that are on stream right now would not be able to see it. But if you have a tablet and you're in portrait mode, so up and down, you might show a list of all the data that you have contained in your app. If you rotate it sideways, well, why would you have a wide list where instead you can kind of take the left-hand side of that landscaped tablet and show other pieces of data? And so when the user rotates the tablet, you can rearrange your fragments, resize them, reorder them, pull fragments out and replace them with other types when the user rotates it. So maybe you get a totally different display when you rotate it. A lot of speedometer apps will do that. So for example, if it's in portrait mode, it just shows the like a big gauge of how fast you're going, and then maybe a couple pieces of details underneath. When you rotate it, it now puts that gauge, the speedometer on the left-hand side, and then it puts another gauge on the right-hand side. So you now have two gauges side by side. So that would be an example of manipulating and changing your fragments based on something, whether it's a tablet, whether it's an orientation change, whether it's a user setting change. There was one app that I had a friend develop, and he was like, I want to be able to customize, this was for a fitness app, customize the UI based on the user's fitness program by dragging and dropping and arranging different fragments on each other. And so he just defined all these different fragments, and you would add the fragments to the screen and basically make your own layout. And you can only do that, well, I guess you could kind of do that with activities. It would be programmatically intensive. I wouldn't recommend it. But with fragments, all it takes is just adding the fragment to the UI, or the layout, excuse me, and then as you drag around, maybe do like relative layout, you would change the coordinates of that. And that's a very simple operation. But anyway, let's get through this. Fragments should not care which activity they're in. So as an example, a Google Map fragment should not care that it is located in an office activity or an office information activity or what have you. They should be, the separations of responsibility should be separate. So, and then move all the logic into the fragment, keep activities simple. So really the activities now are responsible. So in the past we've put all of our logic in the activities. Now we're going to try to keep activities very simple, and basically we're going to keep them as simple as, here, just display this fragment, or this fragment is no longer needed, so we're going to take that out and display this other one, or we're now in landscape mode as opposed to portrait mode, so now rearrange the layout. And there's some other stuff in there that you might keep, like when we talked about the observer pattern with event bus, we might still do our registration in the activity if the activity cares about that. But we can also now do that in the fragments, because we can register as many observers in event bus as we want to. So I'll give you an example of all of these. We'll go through and as we build this out here in a second. So again, activities versus fragments. Every piece of knowledge must have a single, ubiquitous, authoritative representation within a system. So I got this definition from somewhere. I probably should have cited it. Maybe I made it up. I don't remember. This is some old notes. But again, this is what we want our fragments to do. We want to have that Google Map functionality have a single, unambiguous, and authoritative representation within our system. So anytime we want to map, it's that fragment. There's another thing, kind of as we talk about architecture, there's this concept called you aren't going to need it. And oftentimes, I used to work on a project, a long time ago, it wasn't the last place I worked at that you may know about, it was a couple places ago that I worked at, was really guilty of over-engineering stuff. Like, I'm a big fan of engineering. Like, I'm a big fan of design patterns and proper architecture, but there is a point where you are creating hierarchies of, let's say, 3 hierarchies deep. So you have a base class, then you have a subclass, you have a subclass, and you have a subclass, and you only ever use that very bottom child class. It's probably a good example of over-engineering, because you don't need to have all of that inheritance and polymorphism when you just needed one class to hold your data. It's nice because, yeah, it's scalable and expandable, but again, you probably aren't going to need it. Requirements change, but they don't change that much, usually. And oftentimes you can kind of see that anyway down the road, and you're like, well, I do need that 6 months from now. But if you're like, I'll just do it because I might need it, it's probably something to keep from over-architecting. There's a practice called XP, or extreme programming, where 2 or more developers will sit in the same screen and work through a problem. And so they just do the simplest thing that could possibly work. So as you're sitting there with your partner, you just basically just do the most, just not over-architect it. This is essentially another example of that. And then finally, any software engineering problem can be solved. This is one of my favorite quotes. Any software engineering problem can be solved by adding a level of abstraction, except of course, too much abstraction. So what does that mean? We're going to pull out, a lot of the times in the examples I've showed you, we've stuck all the information or all the logic in our activities. When you have that data in the activity and you're trying to get access from another activity or another fragment to that activity, well, now you have references to all these different activities. So what you do instead is you abstract that data out into a separate class, and that will solve your problem. And so, as this quote says, any software engineering problem can be solved by adding a level of abstraction, except of course too much abstraction. So when you have too much abstraction, that's a whole other problem. So you'll see me, this is a pretty famous quote. I don't know if it's attributed to anybody. I did try to look up who actually said that. Can't find it, but we'll do a lot of abstraction rather than trying to stick all of our logic in one class and just making a mess of it. We're going to abstract a lot of that, or extract and abstract all of that information into separate classes. Any questions so far? All right. Everybody seems happy on the stream, so if you have any questions, just type them in. I'll try to keep an eye on the chat. All right, so this is an example of an application that I architected before even building it, because I wanted to make sure I knew what I was doing and where, if I needed to write a piece of code, where it needed to be. Now, sometimes this will change, obviously, right? You realize that you need another piece of level of abstraction and yada yada. But what we have up in the top left-hand corner is two views. One is a map view and one is a list view. These are just fragments, so it doesn't necessarily dictate whether they're where they live or what they have. But as you can see, they have, I think I drew those arrows in the wrong, I think they should go the other way. Sorry, I'll update that. But the map view is a fragment that has a member called map view, so that is the actual map. And we'll see this. I'll show you an example of maps. It's like a two-step process where you add the map and then you got to go get an API key from Google, and there's a couple steps after that. But anyway, it's an involved process, so we won't do it today. But then inside that fragment, I have an add button, and that's going to add a pin to the map. And so when I tap on that button, so it's a button, it has a click listener that will call a function called add pin, and then it'll add a pin to the map. And then I have another one called update map. That update map will actually get called by event bus whenever anybody adds a pin, because if you look at the list view, kind of on the right-hand side of our left-hand side here, we have a list view, and that's, instead of showing all the pins or all the, let's say, addresses on a map, we're going to show it just in a list. So in this one, we have a list view, which is under the hood, it's a recycler view. And then we also have an add button there. So determining whether I'm on a map view or a list view, I can still always add an address or a pin to either the map or the list. And then I call update list whenever I add that pin, and that'll go ahead and refresh the where the recycler view, which is just a list view, where that gets its data. So again, if I'm adding a pin from the map view, I need the list view to also add that row in the list, and that's where we're going to use event bus, or the observer pattern that we talked about a couple classes ago. All right, so those two views live in, are a part of the class. And I think I have those arrows correctly. So this is UML. There's particular formatting of it. They live in a class or an activity called details activity, and that's just going to have a name text field and a description text field. So you're just going to add a name and a description, and then there's and I forgot to add it. It should be a minus sign in front of save pin. But that is a function that will add it to some kind of storage. So the storage is a buildings controller. So this address is an address of a building, obviously, or maybe I should have called it an address controller. But anyway, the buildings controller is a singleton. So that means there's only one buildings controller because, again, if I'm adding an address to this object, I don't want to have to search multiple building controllers. I just want to be able to say, hey, can you get this particular address or this particular building? So I have a couple class methods, which is denoted by the plus symbol. Again, just UML format if you've never seen this before. And we have one called add building, and it accepts one parameter, namely the building object, which I don't have listed here, but just has a name and a description as strings. And then we have one for removing a building. So we want to remove it from the list, and then we want to get all the buildings. So we want an array list of all the buildings. And again, these are class functions. So anywhere in my code, anywhere in my application, I can call buildings controller dot buildings, and that'll always get me the most up-to-date list of buildings. So this is a really nice feature because, again, from my list view or my map view, I can always get this one version of that list view. I don't have to pass it back and forth from activities or other objects. It's just in this one single object. This one single object has a reference to another singleton called web services. And this is just kind of a generic object that communicates with a server. And so we'll cover that as well. We'll be using the retrofit library for that. I believe it's made by Square, the company Square. They just open source it. It's a really nice library. But anyway, it will download, say, a JSON object or a JSON file, pull that in as an object, parse it, put it into what we used to call Pojo, but I don't know what they're called in Kotlin, I guess. Plain old Kotlin objects, so Poco. Whatever. Anyway, it's just a plain old object that we can then start having getters and setters operate on that data. But that's all handled with the web services. So at any time in my application's execution, maybe preferably at the very start of execution, so as soon as I launch that application, what I want to do is I want to send off a web services call to retrieve all of those buildings, because that operation might take a half a second, it might take 3 seconds. And so maybe we can streamline the loading of the UI by doing that as soon as we can. And as the UI is loading, as it's bringing up the buttons and everything, we wait for that to happen, and then the data comes in, and then we update the UI. So what that would look like if we launched the retrieved buildings, which again, will download the JSON, parse it, do a bunch of things, create objects. It does that, so we call that, and then our map view gets loaded. And so as the maps, tiles are getting loaded, yada, yada, that gets loaded, and then our buildings are ready. Then our maps or our pins get added to our map view by calling update map. And who calls update map? Again, this is a call that gets triggered when we update a pin. So this add pin in our list view will trigger update map. But also, when we're done retrieving the buildings and we're done parsing it, it will also send off a notification saying, hey, there's new pins, there's new buildings, there's new whatever. And so update map will get called automatically, but in a decoupled manner, because we never want to, as you can see in this diagram, web services is never connected to our map view. It just, there's a event bus object somewhere up there that I don't have listed here, but web service will say, hey, event bus, post this notification that I added a pin. I don't care who's listening to it, but go ahead and do it. But our map view and our list view care about that action. So we'll go through all this in code, but again, I want to show you where we're going and how we're going to get there. Because as I build this out, I don't want to be like, okay, what objects do I need? What am I going to call it? I might rename these because these are probably a little bit confusing. But you're asking, okay, well, the web services, you said the web services downloads the JSON, parses it, creates those objects, and then adds it to the buildings controller. Well, as you can see, there's no back reference from the services to our buildings controller. And not only that is we do not want to put the logic for constructing buildings or addresses or whatever data is in there in the web services, because that's not the responsibility of web services. The responsibility of web services, if you go back to the concise and single, and what would I say? The single, unambiguous, authoritative representation in a system, our web services will only get a URL, namely to a JSON object, and say, go and download that, and handle the streaming of those bytes, the construction of the data stream, and then finally saying, okay, I have all the data. It was a 200 success response from the server. I have all the data. It's a string data, or it's JSON data. What do I do with it? I pass it to the buildings factory on the right, which is also a singleton. And we call a class function or a static function called create buildings from JSON, and we pass in that string that we get from the web services. So the web services never needs to know what a building is or how it gets constructed, because why should it? You come in as a contractor or an intern, and you need to fix a bug. You're like, okay, there's a bug when these buildings are getting constructed, adding the address, the zip code is missing. So as I'm trying to parse the zip code and pull it out and stick it into the building object, because the building object has a zip code member on it, it's just not working. And so you go through all the code, you can't find it, you don't know where it is, and lo and behold, it's in the web services. That doesn't make sense. But the factory is a design pattern that we use that accepts raw data or raw whatever, either data or objects, it could be several objects, and spits out a finished product. So if you think about a car factory, that takes in, it doesn't take in raw steel, but it takes in, let's say, sheet metal and different parts from other places, yada yada, and out the back of the factory comes a brand new car. So again, that metaphor, I think you can grasp that. What we're sending the buildings factory is just a bunch of string, a bunch of data in a string, and then the buildings factory is responsible for the error handling. So for example, if the zip code is not in the response from the server, the buildings factory can either throw up an exception or just ignore it, or if it's an unexpected value, so a zip code is usually a number, but if you live outside of the US, sometimes there's letters attached to it. So you might be expanding your application to handle, I'm not sure if Canada has, they don't call them zip codes, but I think they have letters in their postal code or whatever that particular piece of data is, and maybe your server is trying to reuse that field. Anyway, all that logic could be taken care of in the buildings factory. All right, so long explanation. Let's jump to the code. Oh, there was a question on the, sorry. So the question on the stream was, what arrows are backwards? So I think you're talking about when I mentioned that there is a connection from the buildings controller up to the web services object, but not back to, from the web services back to the buildings controller. So this is not a inverse relationship, because web services should never know about the buildings controller. It should just know that somebody wants me to call this function. I'm going to go ahead and do this function, and I'm either going to return that data or post it up as an event on Event Bus, or maybe I do both. That's actually, I do that all the time, is I do both. Sometimes you want it directly, and sometimes you want to put it up to other objects. So why does it not go backwards? Again, there's no connection from the web services to the buildings controller, because that would be additional coupling that we don't need. And so in UML fashion, yeah, web services might be returning. So let's say in buildings controller, we start here. We go up the ladder and call retrieve buildings. Retrieve buildings calls the building factory at the end of the at the end of downloading the data, goes to the buildings factory, calls create buildings. Yes, the first one, because I have one to do a single building and then an array, depending upon your needs. So create buildings from JSON. That returns an array list. That returns it to the web services. Web services doesn't need to know well, it's just an array list, but it doesn't need to know what's inside of that array list. Maybe it's just a generic array list that gets sent back. And then web services returns that to the buildings controller. But in UML, in the UML diagram here, we don't put an arrow back because web services doesn't have a reference to the actual buildings controller, it just returns it. So yes, it passes the information back, but it's, I mean, you get it. It's you're returning that data without actually returning it to a particular object. So anyway, I hope that answers your questions on the stream there. Yes, thanks for asking. Sometimes I blow through things. Sometimes I over-explain things, and sometimes I gloss over things. So do stop me, or do this with your hands to like, come on, well, you get it. Thank you. Keep moving. But yeah, all this is important. So sometimes I'll take a little bit extra time. All right. So we got another question. Is this what you were referencing earlier? I'm not sure what you mean by what I was referencing earlier, but yes, all the stuff that I talked about in the previous slides, that diagram kind of illustrates a lot of those different things. But we'll go through the code now to kind of illustrate some of that stuff. So in this application, I'm going to keep my diagram available. We have a map view and a list view, and that's going to be contained in a details activity. I'm going to rename these a little bit just to fit into our existing code, but I have a main activity, and this main activity is going to have subfragments. Okay, there's another question. You said the arrows were wrong. Oh, okay, I see what you're saying. Thank you. So the arrows are pointing from the map view to the details activity. I think that's wrong because it's the details activity that has a reference to the map view. So that's why I think the arrows are the other way. But sometimes in UML, and again, I'll have to look this up before I correct this, but sometimes in UML, you're just saying that this object is contained in that. It's a little confusing, but I think I have those backwards. Don't worry about it for right now. It has nothing. Doesn't really impact what we're talking about, but I will look that up and try to fix that. It's just UML. You can look up what a solid line is versus a dotted line, and etc. Okay, so in our main activity, we have different fragments that are going to get added to it. So in this particular one, we have one that we just created called the gallery fragment, and we can take a look at that layout really quickly. Should be this one, and this one just had a text view, an edit text, and a button, no big deal. And so in our diagram, let's see, camera. We're going to change this up a little bit. Let's say my slideshow. This is not going to be a slideshow, it's going to be a ListView fragment. So I'm going to create that first. So in my package, right click on it, go to New, drag it all the way down to Fragment. And I'm going to create a ListView fragment. So I haven't really talked about these yet. When we create a ListView fragment, this is going to be a table or a grid of items. And so what items? It will create that for me. So it'll create an object called item. We can name it whatever we want. We'll create the fragment that will contain this list. So you can see it's a whole bunch of rows. The column count. So if you want, instead of just a single column, we can have more like a grid, like I mentioned, like a two column grid with as many rows as you want, or a 3-column grid, or a 4-column grid. So we'll just do one for right now. Object content layout file. So what is the layout file name for this? We'll change these to something a little bit more descriptive, but just go through these. The list layout file name. So this is going to be another layout file, as you can guess. The adapter class. An adapter is another design pattern which allows us to plug in different either data sources or classes into the same interface. So if you think about an electrical outlet, we can plug in a laptop, we can plug in a fan, a monitor, whatever. That outlet is an example of an adapter design pattern because it has the same interface, namely the two vertical lines, and one's bigger than the other in some of those outlets. But again, you can plug in different objects. So a good example of this is payment system. So let's say you have an application that you're running, and you have a payment system that will accept PayPal, it'll accept Apple Pay, Android Pay, credit cards, etc. Whatever payment system you can think of after that. But we have 4 different payment systems, but they all have to come into your application. So instead of writing different code that lives in different parts of your application, what you do is you write different adapters that take those external payment system, translate those into one unified format, and that one unified format goes into one adapter in your application. So your application is only exposed ever to a single data structure for your payment system. No big deal, but we're going to use this for our RecyclerView, and then obviously which language we're going to do. So for this one, we're going to stick with our, let's say it's photos. So I'm just going to call this photos. It's not really going to have images, but we can pretend. And that renames this to photo fragment, fragment photo for the layout name, fragment photo list for the list layout, and then photo RecyclerView adapter for that adapter view. So just a nice way to create all these different objects that we're going to go through. And then Git is going to ask me, do you want to add all these to the Git repository? So yes, hit OK. Gradle needs to build all those. Come on, there we go. Apparently enter doesn't work. Go figure. All right, so let's go through this really quickly. There's a lot of code here. We'll go through this a couple times in other example applications that we build. But yeah, I didn't want to call it my photo. I thought it was just photo RecyclerView. I hate the keyword my. It's like, yeah, I know it's yours. It's there. It's in your application. Anyway, I digress. Okay, so this one's going to have a list of dummy items. Those dummy items are in this folder called dummy, so we can obviously rename that. Let's go ahead and rename this. I'm going to right-click on this and go down to refactor, rename, because that'll rename all those dummy content items. I'm just going to call this photo should be fine. Okay, give it a second to rename all that. All right, so inside of photo, this is, it contains an object in here, and this object allows us to have all of this data within a class. It's not quite a companion object, but it does kind of give us a sub-object within this. It's not quite a, well, excuse me, it's not a class. It is more like a struct, I guess, if you're familiar with C-based languages. It doesn't have as much functionality as as a class. Anyway, it's not really that important, but let's just go through this. So in here we have an array list of dummy items, which let's see. Hold on, sorry. Oh yeah, okay. We renamed that. Let's say that doesn't make sense. Let me rename this to photo content. That's why I was like, that doesn't make sense. Okay, then we have this dummy item, and that dummy item is going to be defined down here in this object, again, not a class, an object, as a data class. So if you remember, data classes are classes that just contain data. They will automatically add a getter and setter depending upon what kind of parameters are set to. So this particular value called ID of type string will only have a getter. It will not have a setter because val is a constant type, right? So you can't set a constant or reinstantiate a constant. So in this one, we just have an ID, it has content, it has details. There's not You can change these if you want to. We're going to keep these the same. And there is actually a function, but that just returns a string of all the content that's in it, or excuse me, the one parameter here. Okay, so that's where this comes from. Actually, let me go ahead and rename this as well. We're going to call, oops. No, too far. Okay, let's try this again. Really carefully this time. Refactor, rename. I hit delete when everything was highlighted, so that's why I did that crazy thing. We're going to call this photo item. So photo content contains all of this logic, and then photo item is just the data class that contains these three values: ID, content, and details. It has this helper function, which is a private function called makeDetails. It's just a for loop that populates this array, the array list. Create dummy item is just the name to call the constructor. Add item will actually add it to the that array list, or actually this is a hash map. No, that's a map. This is the items. And so all of this code is kind of like our controller. It has the ability to add an item. It doesn't have one to remove it, though you can guess how that would work. And then it has the ability to return all of our, in our case, photos, which is the ability to just call items there. Okay, so this is just setting up some dummy data or some test data that we're going to use. All right, so that's what that does. In our photo fragment, this is pretty much what we saw when we created our fragment last class, with the exception of, well, let's see, on fragment, yeah, so it does have this interface in here. We didn't have a choice on that, so we do have to implement that. So I am going to go back to my main activity and implement that, because I always forget. So what that means is I am going to say photo fragment dot on list fragment interaction listener. It's going to complain. Let's see. Yep, there it is. So click on the red squiggly, click on the red light bulb, and say implement members, hit enter, and that will add the function that will not allow your app to crash. So if you remember, we added in our last class this interaction that gets called. I'm going to comment this out because if it gets called, it'll throw an exception, or it'll be an assertion, crash the application. So you should be implementing these, and if you need to. So basically what I'm saying is we're interacting with the fragment inside of it. This is just a way to communicate from your fragment back to your activity, just as a quick reminder. All right, so we have the photo fragment. It looks almost exactly like our gallery fragment. And here is our RecyclerView. All right, so this is kind of the meat of our lesson today, is the, or one of the main pieces. It is the ability to scroll up and down through a list. They're called RecyclerViews. They used to be called, well, there was another implementation called a ListView, which I still use because it makes more sense. It's more intuitive than RecyclerView, because you're like, what does it recycle? Plastics, you know? But what it recycles is, as you scroll up, and actually let me go ahead, well, okay, I'll explain it first. I got to do one more operation before I can show it to you. But as you scroll up, what happens is the rows that go off the top of the screen, they come off that stack and they get added to the bottom of the screen. And so at any given time, maybe there's like 8 rows visible. There might be, say, 12 rows in all, but maybe your application can show a total of 1,000. Well, you're not going to create 1,000 rows because more often than not, you're not going to show like the bottom 100 or excuse me, 900. And so why create in memory all of those rows and all of those objects when you only need basically 12? So again, there's 8 shown on the screen. There's a couple on the top, a couple on the bottom. As you scroll up, again, it takes the top row off the top, puts it on the bottom, just like a treadmill. If you kind of imagine a treadmill where the top is the part that's visible, as it goes at the top of the treadmill, it kind of comes around, back around, and then the bottom. Well, as it's in the background, as I say, the bottom of the treadmill, to keep our metaphor, it's getting updated. It's getting updated with data. So that row that was at row 0, as it goes up the top of the application, it then becomes at the bottom of this treadmill. But before it does that, it gets written as, let's say, row 13 if we're having our 12 rows. And so row 8 will scroll up, then you'll see 9, then you'll see 10, 11, 12, and then 13. That 13th row is now displayed, but while it was doing that, it was also taking rows off the top and putting them on the bottom. Sorry for the people on the live stream, but you can't see my hands waving back and forth. I don't have a marker to write on the whiteboard today. But anyway, I think you get the idea, and so we'll go through this. Actually, yeah, let just implement that code before we go through this code. Let's see. So in my main activity, we want to do the same thing. When we tap on the left-hand side in the menu, on the left-hand side, as I mentioned, it'll go on the right-hand part of our content. So I'm just going to copy this because I'm lazy. Paste it in there. I don't want to type all of it in there. And just change the value. So instead of a gallery fragment, we're going to call photo fragment. We haven't instantiated that yet. Change this name to photo. We'll keep everything else the same. So we're just taking the photo fragment and placing it into our main content view that we set up last class. Okay, so this obviously is not instantiated, but we will do just that. So we'll say photo fragment equals photo fragment. Okay, and then create it as a member so it sticks around in our class. We make it optional, and just want to check one thing to make sure our fragment package is correct. So if you remember from last class, this is v4. This is our support library. I don't remember which we're using from last class. I'm going to double check that. So indeed, we're using just the android.op.fragment. So that is wrong. I'm going to copy that. So if you look in our gallery, that's what we had the issue with last class, was the gallery fragment. It wasn't liking the fact that we were using the support library. It was expecting this package, android.app.fragment, but Android Studio, for some reason, even though it knew we were not using the support library, added that library in there for me. So if we went to go compile that, so I just want to make sure we ran that first. It's good. We got some activity on the live stream. We gotta make sure I keep my eye on it. There is a slight delay on the live stream. They got it's like 20 seconds behind. So I'll ask it and then be like, no questions, go on, and I ask a question and I miss it. So anyway, okay. So now we go to open up the menu. We go to slideshow, which will show our photo fragment, which we have the RecyclerView in, and we'll show you how this data gets populated, but you knew how it was instantiated. I'll show you how it gets added to each row. But again, as we scroll up, row, in this case, numbered 1, it's obviously 0, but 1 comes up, and then 13 is at the bottom. That may or may not, I don't know what the memory footprint looks like. I don't know if that was originally at the one place, but one is now somewhere off of our screen, comes back around to the bottom, and maybe comes in at row 13, maybe it comes in row 14. So what they do, what Android does, is it keeps a couple rows at the top that actually have data. It actually has these pieces of data written to that UI. Because you can imagine, as I'm scrolling up and down, I'm constantly writing data to these rows before they get shown to the screen. And then as they kind of scroll up, we're just updating the graphics. And then as it comes off the top, we pull that off of that stack, put it at the bottom, and if we're scrolling the other way, it does it the other way. And that's why it's called a recycler view. It's recycling these rows. How many rows are in here? 25. Okay, so how does this all, if we go to our photo recycler view, excuse me. It's called an adapter, but it has the item. If I go back to my diagram, this is my list view, and it has an object in there called ListView. So we now use recycler views. So we have a recycler view adapter, and inside of our recycler view adapter, we have that, that recycler view. So how does that actually get populated with the data? Say I want to change what's displayed on there. We have this inner class called view holder. So that is the actual row. We pull out from our recycler view, we say, okay, we have this, this particular row that we're trying to get data for. We pull that out into this guy. Oh, yeah. So, oh, sorry. These are just getting references to the two text views. Sorry. So this is really what we want. So we are doing the number, and then the basically it says item 1. Sorry, the text here. Okay, so 1, bunch of spaces, bunch of other things like that, and then item. Okay, let me show you the layouts for that. So if you want to make a custom layout for that row, maybe you don't like the fact that it just has that text view in there, maybe you want to add an image view. So we have in here our list view, which basically just contains our, yeah, this guy. And sorry, it was like really small. It is wrapping the content, so there's no content pre-populated in it, so that's why it's really small. So we have the item number and we have the content, and again, these are both text views, excuse me. So we're looking at the code, text view 1, text view 2. If we wanted to add an image, as I said, what am I looking at? Image view, we would drag this in somewhere here. I'll put in the hierarchy, let's say like it's a bunch of users. Still couldn't get this working. So obviously it puts the image there, but I would have to have an image in my project, or again, go download it off the internet. That's not where I wanted to put it. Okay, and then let's put some default data in here that we can programmatically change. So maybe just like a placeholder for the number, just so we can see what we're doing. And then like item, something like that, right? And so again, you can define the layout for your row, change this up, add additional elements. You can put buttons on it, whatever you can think of for this. But you get the idea of how to construct that one row. Okay, if we go back to our, there's one more thing I want to change. If we go back here and choose gallery, what was it? Oh, awesome. Let's say that wasn't working. Go to our logcat, see what happened. All right, let me fix what I was going to do before we worry about that. I'm not too concerned with that. In my main activity, last thing I want to show you today is oh, I remember. I was trying to get this to work because the UI wasn't showing up and it just happened to be how we had it laid out. I had this as replace. So what it was doing was just adding fragments on top of each other, which is probably what happened and why it crashed. Okay, so the thing I wanted to do actually was normally the camera would be our first view, but let's say it's not. We'd have to reorganize that. When I start up the application initially, you may have noticed that it has a blank screen somewhere. Come on. Okay, blank screen until we select an object. So obviously bad user experience. So the last thing I wanted to show you was after we instantiate our fragments, let's go ahead and add some default one to it. Yeah, gallery is fine for now. But we can call replace, but let's just, yeah, we'll just do add. Oops, not Control R. I hit Command R instead of Control R. That'll do replace and find replace.
Did you say that your fragment managers, if you'd want to keep your main activity there, you would want to pull that out of your, when you were talking about extracting,
yep.
You would want to pull that out.
The photo, you mean the photo content?
I guess, yeah, that'd be part of it, yeah.
So the photo content is kind of similar to like the manager that I was talking about. It is its own object. It has functionality to add photos to it, and it doesn't have one to remove it, but you can add that. So that's kind of our abstraction.
Gotcha.
Yeah, and where our RecyclerView is pulling the data out of, it's going to the photo content object and asking it for each piece of data. So there's some questions on the live chat. They want to see the photo in the emulator. I don't think it doesn't work because I don't have it adding to it. But so this one obviously showed the default. So we go down to our slideshow. Yeah. So just because you add the image view, I have a placeholder in there, but the placeholder doesn't actually do anything in the app. You have to actually add an image to it. I can set that up for next class. We're kind of short on time, but if what you would do is you would put it in, you would take an image like a PNG file, put it into your resources folder, and then load that up. So once you have that, this guy, so image view, I think I did this for one class, but let's put something in there. Normally you'd get these images probably from a web service or something like that. So this is just a built-in icon in Android. But again, I'll set it up next class where I'll download a PNG from the internet, put it into our resources folder, and then you can use that same source compat to get a reference to that image in your resources folder and then display it there. But that's a quick and dirty way of just showing something for you. And yeah, any other questions? Cool. So for those who missed I announced it at the beginning of class on the live stream, for the 11 of you that are on there, I will be moving the live streams to a Twitch stream. So I'll send out all the information, and you can just For some reason, if you don't get that information, just look up Electronic Armory on Twitch. You'll find it, and that'll be obviously next Thursday. We'll do that. So, all right, guys, thanks for coming out. Don't know if it's still snowing, but stay safe out there. It's probably starting to freeze over. So,
It's like rain, snow.
rain, snow.
It's like it's it's feeling good.
Picture brick.
Oh,
He doesn't use it.
You know, you mentioned homework.
Homework, yes. Thank you. Let me cover that really quickly. Yes, thank you. So I mentioned I was going to talk about the homework, and then I didn't. So yes, thank you. I will send this out. It doesn't have a due date currently. So real quick, homework 3. This is where you are going to choose your final. I know I don't have everybody's feedback back to you for homework 2, so maybe you're kind of on the fence about which one to choose. So I won't make this due until well after I get everybody's feedback on, or yeah, get you back your feedback for homework 2. But I just wanted to give this to you so you can start thinking about it. Let me finish answering this question in the live chat. I was typing it in. I spelled programmatically wrong. The question on the live chat was how to make all those images different. There's a piece of code, I'll show it later as I'll fix this up, that it'll ask you, what should I display for row 0? So there was that line of code that says, show item 1, whatever that value was, show the row number. That's where you would have an array of image bitmap data. You would say, okay, go get the image data for row 0. And if it's in an array or a part of an object, you just go into that array and say index at 0 and then grab that out and display it there. So we'll do that next class as we go through this. I'll hook up Event Bus. I'll hook up some other stuff to show you how to do all these larger tasks. But yeah, so sorry. Homework 3. Too many tasks. Okay, so choose one application, obviously, to do your final on. This is something of your choice. I will give you feedback on the options that you gave me for homework 2, but it's really up to you. So I'll say this is a terrible choice to do for a final. You're still welcome to choose it, but don't be surprised if you get a lower grade. Or I will give you feedback and say this is how you improve it, and then just take my feedback and do your own thing with it. And if you have any questions, obviously I'm here to help you. But requirements for homework 3. I need you to draw and design wireframes for each major screen of your application. So if you are a restaurant finder, when you load up the application, what do I see? You don't have to draw a splash screen, but the initial screen might be a map. It might be a list. It might be it might be a sign-up screen. So that way you could see, well, if it's a sign-up screen, that's probably not the best introduction to your application. But showing a map based on your location, maybe that's a little bit better because you can instantly start getting into your application. So start drawing these wireframes. If you want to, you can link them up, though that's not a requirement. Draw arrows and say this screen launches this screen. You can use Adobe XD like we talked about. The last part here, settings and other supporting screens, you don't have to do that. So if you have like a profile edit screen, don't waste your time. Unless it's really exciting and you want to plan that out, go for it. But again, I'm not going to require every single screen. But if it is a major feature in your application, such as a map view or the ability to add data or something like that, yeah, definitely put that in. Number 2, list all major features of your application and additional technical features that are required for each feature. So as an example here, we have a car maintenance application. The features of my application, it reminds the user to change their oil. However that works, that's up to you, obviously, but that is a feature. I forgot to mention that that would use a local notification. It would push a notification out to the user. Keeps a searchable database of different parts added to the car. So maybe I'm using an Acme oil filter on it, right? So you can add those to a database. that technology would be, I'm adding a database. Maybe your application is a restaurant finder. One of the technologies would be going out to the internet, so using the internet or web services or networking to draw on that data, and then maybe you take that data and put it into a database. So anyway, list out all the features and then what technologies those features use. Maybe you use Bluetooth, maybe you use the camera, etc. Describe the design style based on your demographic. So if your application is a car maintenance application, that demographic is probably going to skew, let's say 60% men, 40% women. That might define how you design your application, the style, the color scheme. If your application, to be very blunt or very extreme, is a I don't need it, but finding a haircut. I want to find a men's salon. Somebody posted actually the other day on this app, the local neighborhood app. It's like, is there any place around here that does men's haircuts or a men's salon? I forget what they said. If that is your application and you are tailoring to men, then yes, your demographic is men, and that will affect your color scheme. One warning about that is don't be stereotypical. So for an extreme example is women, right? Don't make the application pink unless you have a really good reason for it. It's just kind of, I don't know what the right term is. I don't know, so maybe that is your demographic. But give me a reason why. Just say we're going to make this because our demographic is 60% men, 40% women, so we're going to kind of skew toward this color scheme or this or harsher, sharper edges, that sort of thing. So come up with that. If you need examples, let me throw this at you really quickly. I think I spelled that right. No, it's 2 R's. I hate these sites that I can't remember. Oops. Ancestry. Sorry, I was trying to do this really quickly. Here it is, I think. No, that's not it. Top one, yeah, sorry. I never click on the top one because that's always the advertisement. Okay, so for your design styles, for your wireframes and stuff like that, if you need inspiration of how to set up different design layouts, this website, and again, PTTRNS, I guess I missed the S, you can say, all right, well, I'm going to do a wireframe of my login page. So you can click on logins on the left-hand side and see how other apps do it. Some of these are iOS applications. So you can, this one's iOS. Doesn't mean you can't use it for Android. Some of the design, like obviously the keyboard, but some of the design is specific, but most of the time it's not. How to display photos. Anyway, if you need design inspiration, like I always do because I'm a terrible designer, I just go on here and say, yeah, that's kind of the look I'm looking for. So anyway, for number 3, describe the design style. When you do your wireframes, they don't have to be stick figure type stuff. You can get a little bit more specific. Number 4, in no more than 1 paragraph, so about 3 to 5 sentences, because sometimes people need that defined, describe your app to a potential customer. So this is your elevator pitch. This is why I should download your application, actually mainly why I should care about your application, what your application does, and then why it's worth it to me. So you can put that in any order you want to, but it is your sales pitch. I ask you what your application does. My application is a restaurant finder for Boise, Idaho. Mine is a cart maintenance application that makes sure that you change your oil every X number of miles, right? That's your elevator pitch. Give it a little bit more detail than that, but you get the idea. Okay, so thank you for reminding me about homework 3. I will send this out, but yes. See you next class. Thank you, and adios.